in his theory of evolution, produce a very complicated eye like the eye that we have. So they gradually evolved the eye by adding small different features through many small changes. And they go through many steps. Here we have 362 steps from the eye spot to a slightly more advanced eye where you've got a depression which gives you a larger area to collect the light and start to getting light collected together in a kind of pit. And as you go through the process, it slowly changes. Their model of the eye slowly changes till you get to something like a pinhole camera, which is actually quite a reasonable eye. If you've ever made a pinhole camera, you can get quite a decent image with a pinhole camera. And this eye is fairly common in nature. And here they add some more features. You get the lens added, and you get a cornea added. And they claim that in about 1,800 steps you can evolve from an eye spot to a rather complicated eye like the eye that we have. So far, so good. There are a few problems, though. We'll come to that in a minute. And here they say, okay, we can show this is the case because we can look in nature and we can look at the eyes of various creatures and we can show all the various stages actually existing today. So on the top left there you have an eye spot, and in the bottom right you have the eye of a cephalopod, a squid or an octopus, which is a very advanced eye. And they say, look, it happens. Well, actually, as I say, there is a problem. I want to go back to looking at a creature called Nautilus. Nautilus is a mollusk related to, well, in biological terms, related to a snail, although the relationship I would question. But it is a living submarine, very complicated living submarine with a multi-compartmented ballast chamber, jet propulsion. And the interesting thing about this creature is it's found in just about every single geological age. So wherever you look in the rocks, you tend to dig up a nautilus or something very like a nautilus. And here's a nautilus swimming across the page for you. But one interesting thing about this creature is it doesn't seem to evolve. So a nautilus you dig up that's supposed to be 400 million years old looks like a nautilus today in all the essential features. But when we're talking about eyes, the eye of the nautilus is very interesting because the nautilus has a pinhole camera eye, which is not very complicated. Here's a picture of the eye of the nautilus. Here's a diagram of what it looks like. But its eye has not evolved in 400 million years. Now, the whole point of Nielsen and Pelger's paper was to demonstrate it's actually quite easy to evolve an eye. Okay, well, if it's quite easy to evolve an eye, how come the nautilus is still going around with a simple eye and hasn't seemed to advance? Well, I would suggest there's a reason it stopped with a pinhole camera eye, even though the changes are supposed to occur easily, because you need something extra. Here's a pinhole camera eye, and here's an eye with a lens. Well, where does the lens come from? How do you gradually evolve from an eye with no lens to an eye with a lens? Well, that's not gradual evolution. You've added something new. So the question is, how do you add that new thing? Where does that new information come from to give you the lens? And then you've got the cornea as well across the top, which is also part of the focusing system. In fact, you might not be aware, but in your eye, the major lens that does the focusing is actually the cornea, not the lens inside. The lens inside just allows you to read, or not as you get older, when it goes hard and you can't accommodate anymore. So the question here is, why did the nautilus stop with a pinhole camera eye? And it's not enough to say, well, it's good enough, because if it's so easy to evolve a more complex eye, why didn't it evolve a more complex eye? Because it actually would have made it a much more efficient creature. It stops. Well, maybe there's a problem with evolution. But there's more to it than that. The eyes that we have is quite interesting in that it's different from the eyes of something like Nautilus. It's been claimed to be wired backwards. In fact, wired badly backwards. But that's another debate which we're not going into. But I want to just demonstrate another problem with the evolution of the eye. Here we have a light-sensitive cell in the nerve. Let's assume where the light-sensitive cell in the nerve exists. Now, first problem is, where did that come from? Because Nielsen and Pelger assume the light-sensitive cell. Now, the light-sensitive cell itself has got some very complicated biochemistry inside it, which I haven't got time to go into. Where did that come from? So here we have an eye spot, with different light-sensitive cells and all the nerves connected to the brain of the creature. The nerve fibers collected together to form the optic nerve, and here's the outside of the animal. So the light comes in here, detected by the light-sensitive cells, signal goes down through the nerves to the brain, and the animal moves away or moves nearer to whatever it's watching. So far, so good. But our eyes are not wired like that. Our eyes are wired differently. We've actually got a hole in our eye called the blind spot, And if you use the same simplistic diagram of what an eye would look like with the nerves actually go from the top and disappear down through the hole, your blind spot, and then go through to your brain. Now, the vertebrate eye did not evolve from a mollusk eye, did not evolve from a nautilus eye or a squid eye. They're different paths. They'd have to evolve independently. So the question I ask here is, when did the eye change from being wired the right way round, as some people would have it, to being wired the wrong way round or upside down? Well, I haven't yet heard an answer to that question. Remember, what we're doing is we've got to evolve from this to this. And it's not simple to do, because the diagram might look very simple. You say, okay, well, that's simple to do because there's only a few components. But remember, you're rewiring this. And that's not simple. You can't just flip it over. It doesn't work. And there's a whole lot of anatomical reasons why it doesn't work, a whole lot of biochemical reasons, which I haven't got time to go into, why it doesn't work. But I would suggest to you that this is a major challenge to Darwinian evolution, because you can't slowly and gradually evolve from the one to the other. It's an all or nothing change. It's a quantum leap, or a paradigm shift, if you like. So the eye is not irreducibly complex, I agree, but the eye is complex, and the evolutionary explanations are not adequate to explain how we got to it. Let's move on. Richard Dawkins accuses us creationists of worshipping the gaps. We like gaps, he says, because we like to put God in the gaps. And there's a problem with that, and I recognise that problem, and I agree with him. We can't have a God of the gaps, because as the gaps disappear, so does God. So if you just rely on the gaps to put your God in, you're not going to get very far, you're not going to last very long. But that, again, is a caricature of creationist position. We don't actually worship the gaps. We don't actually look all the time at the gaps and say, look, a gap, there must be a God. Our argument is a bit more sophisticated than that. So I want to address that side of the argument just briefly by looking at out-of-place fossils, and then I want to look at irreducible complexity, because this is part of the argument, as Dawkins would have it. We creationists, he says, say something's irreducibly complex. We can't explain how it evolved, therefore God must have done it. And we're going to look at the bacterial flagella as an example of complexity, and irreducible complexity. But let's just go back to some quotes from Richard Dawkins, where the issue lies. He said, if an apparent gap is found, talking mainly about the fossil record, but other gaps in knowledge as well, any gap in scientific knowledge, he says, we fill it by God as a default answer. And he accuses us of being intellectually lazy. And talking specifically about evolutionary transitions, for which there are many gaps, and he admits there are gaps, although he doesn't admit there are as many as we would have. He says many evolutionary transitions are elegantly documented. Well, some of the smaller ones are, some of the big ones aren't actually elegantly documented. And in response to the question that the creationists asked, how do you falsify evolution, he quotes a famous evolutionist, J.B.S. Haldane, and says it's very simple. If you want to prove evolution wrong, dig me up a piece of Precambrian rock with a rabbit. How to falsify evolution? Well, rabbits in the Precambrian. That would answer the case quite nicely. If you can show me a rabbit from the Precambrian rocks, I believe that evolution is no longer true, because that can't happen. And that's fair enough. But let's look a bit more detail at that. Just a quick reminder, a bit of geology here so we understand what the Precambrian is. Here is a diagram of the geological column with different periods. Coming from the bottom, the oldest period is the Cambrian. The Precambrian is before then. And then working up, you've got the Ordovician, the Silurian, Devonian, the Carboniferous, the Permian, and so on. And down in the Cambrian, you've got things like trilobites. And in the Devonian and the Silurian and the Ordovician, you've got fish of different varieties. Birds appear in the fossil record about the Carboniferous, the Cretaceous. And mammals appear a bit later, also the birds are in the Jurassic and the mammals in the Cretaceous. And that more or less is what happens in the rocks. If you dig up these rocks, this is what you find. And there are various questions around that which I'm not going to go into. But I want to move on. I want to address this question about the Precambrian rabbit. Here we have a picture not of the Precambrian but Cambrian, because actually in the Precambrian there wasn't much life at all. A few starfish. But why are we not going to find a rabbit in the Precambrian or the Cambrian? Well, because the Cambrian is an aquatic environment. It's watery. All the life in the Cambrian is living in seas or in lakes, and you're not going to find a rabbit hopping around in the sea bottom. So that's why you won't find a Precambrian rabbit, because